Welcome back for another video. So in this video, this is going to begin the first series of videos that we are going to do on the unified path. So if you have 5-axis, you've probably seen the unified path. It actually used to be about 3 or 4 different paths that were in your drop-down menu here. Whoops, helps if I actually put the drop-down menu. It would be 3 or 4 different paths in here, and they've actually combined them all into one now. This happened probably, I want to say 2021, 2022, something like that. But anyway, we're going to go ahead and go over this. We're going to talk about the way that this is going to work is we're going to start with kind of the process for creating a unified path. So we're first going to go over, actually let's go in here so we can take a look at it. So the first video is going to be on cut pattern. And we're just going to talk about how to get a cut pattern. The next video will be on tool axis control, followed by collision control, followed by linking. And I'm going to go through the process of how to create an effective 5-axis path with the unified. There's kind of a process that you use, and it's helpful to follow that process because otherwise you kind of end up getting yourself into a whole world of crazy toolpaths and it doing weird things if you set too much stuff all at once. So, without further ado, let's go ahead and begin. So, to begin with, I'm just going to pick a tool here, and it's going to warn me that it's too fast for my spindle. That's fine. We don't mind that. Let's see, we got a holder. So first thing in 5-axis, always define your holder. Otherwise, you're not going to be able to use collision control down the road. So when we get to this in our third video, if you don't have your holder defined, it's not going to properly create your collision control. It's not going to properly fix your toolpath so it doesn't collide. So you must define the holder that you are going to be using. You can always change it if it doesn't work out, but you must define a holder. You also must define a proper tool projection. Those are imperative. If you don't do that, you're asking for problems. You're asking to crash your machine. So, moving on. We're going to go ahead and go into cut pattern. So, we're going to discuss 3, I believe. Let's see here. So, we're going to discuss the parallel. We'll briefly touch on perpendicular. I don't really have a setup for that, so I'll just touch on it briefly, and then we'll move on. We're going to talk about morph, and we're going to talk about guide. So the 3 main ones, we're going to talk about parallel, morph, and guide. We're not going to talk about project or wireframe. Maybe we'll get into those in a different video at a later time. So let's go ahead and move forward. So I'm going to delete this first thing, and I'm going to discuss what these here options are. So the first one is an automatic row. So back when these were separate tool paths, right? We would have had parallel, morph. They would have been separate tool. Project was a separate tool path. Basically, the reason that they combined all of these, you'll kind of see it as we're going through. To find the proper cut pattern that you want, you used to have to create one of them, and if it didn't really give you what you wanted, you'd have to delete it, and then you'd go and create maybe a parallel if you started with a morph. Now, by combining them all together, you can just come back in here and you could just change it, which made life a lot easier. So, at first, I really hated this adjustment because it was new and it takes time to adjust to it. But now, actually, I really, really like it because it makes things a lot more efficient and a lot easier to just switch between the toolpath types. Okay, so let's go ahead and, as I mentioned, let's start with one of these automatic rows. So this here is essentially, it's kind of like a canned tool cut pattern. So right here, machining boundary parallel. So let's go ahead and select that, and then let's just grab machining geometries. I just have a 2D planar surface here. That's it. So that's part of the reason why we can only go through a few of these. That being said, I'm going over the most popular ones. So even though we're planar, we're using a planar surface to do these, you can use these on any, well, not any, but pretty much any shaped surface. I use morph on an impeller floor. I use parallel on the vanes of the impeller. So you can pretty much use them on anything. I'm just doing this for simplicity's sake. So don't think that you can only do these on a flat planar surface. So we're going to select this, hit end selection. All right, tire machining area. I'm not going to set a lot of this stuff. So that's the key to this process, right? So you don't want to just set a bunch of parameters, especially if you don't know what they do. All you're doing is asking for trouble there. Now, what I do know is I pretty much know what zigzag means. You could probably figure that out. That being said, I'm just going to hit OK. So I've selected my machine geometry. I want to machine this surface, and I'm going to hit OK. OK. Now you can see right here it created our machining geometry. In fact, actually, let me go into levels and let me turn off our surface. So you can see right there, that's our geometry. And what this parallel does, in fact, let me go in and just kind of highlight it again here. So machining boundary parallel. Basically what it does is we've picked that square planar surface. It's looking at that boundary, that square boundary, and it's saying, hey, I want you to create the toolpath parallel to that. So it's basically just offsetting that a bunch of times in. Now, you'll notice here we have these connecting moves. This is because we've selected zigzag. So since we're zigzagging this, it essentially does one full revolution and then it transitions to another one, goes around it, comes in, transitions to another one, and it's just going back and forth. So it's going like that, but it's going the whole way around. So if we change this to, so if we change this to one way, it would go one way, but it would still have connecting moves. So we're still connecting. So it's going to climb the whole time, or conventional, depending on which one we pick. Now I could change this to spiral, which frankly would be an ideal one for this. So now you notice there's no connecting moves. So it's just spiraling in the whole way. So it kind of gives you a little bit of an idea of your cutting method there. You have kind of three options. Usually there are some other options depending on what you pick. Okay, so that's machine boundary. Let's see here. So we could do surface boundary parallel. Now, this isn't going to change anything, right? Because the boundary of our surface is still that square. So it's just looking at the boundary. Let's go back in here. And let's go center parallel. Okay, so now what it's doing is it's actually creating a true spiral from the center, and it is going to offset those each and every time. So it's not going to use the outside boundary. It's essentially going to create a spiral and spiral its way out to the outer boundary. So a little bit different cut pattern. Probably not ideal because you see all the retracts that we have here. That doesn't look very efficient, right? So probably wouldn't choose that unless I needed to have some specific lay direction for the machining pattern. Let's go to... So let's go ahead and go to morph, and we'll do machining boundary morph, and we'll hit check. All right, so now it's taking the outside boundary and it's starting that and it's morphing it in to a true spiral to the middle. So we talked about parallel. We looked at parallel, and parallel basically just offsets the shape in. Morph will morph from one shape to another. So it starts out as a square on the outside, and you can see it slowly transitioning. The further it gets in, the more round and the more round it gets, the more circular it gets in here, until we're basically creating a circle in the middle. So morph will basically morph it from one shape to another shape. Now, since we didn't select the other shape, which we'll go over that, it's basically just morphing it to a circle. No matter what the outer boundary is, it's going to morph it into a circle or a spiral. So these are kind of easy, canned options. I don't use these much. Usually I like to be a little bit more specific. They work really well on a flat planar surface like that. but they don't work as well when you have, you know, some sort of amorphous shape that you're trying to machine. Surface boundary morph, that's essentially going to do the same thing, because the surface boundary is the same as our machining boundary, so there really wouldn't be any difference here. We can do center morph, and essentially it's going to do the same thing. It's going to spiral out, it's going to morph out to the outer boundary. Okay, so let's take a look at some other options. So there are the automatic rows. Again, kind of canned. You don't have to select any geometry. Just select what your surface or your solid, and it's just going to create one of those cut patterns from that. So let's add a curve row. This is generally how you're going to do it. So in a curve row, we have a couple of options as we looked at earlier. We have parallel, we have perpendicular, morph, project, guide, and wireframe. So as mentioned, I'm only going to go through 3 of these. I'm going to touch on perpendicular. So let's start with parallel. So when we grab parallel, we have no entities selected. So when we pick parallel, it's these entities, it's asking, what do you want to be parallel to? Okay? And to select these, I have to pick this down here. So I'm going to select them. And let's go and select that whole square. And we already have our surface selected here. So you see it says 1. So I don't need to select that again. So I'm going to hit check. And lo and behold, it makes the same pattern that we did with the parallel boundary, the automatic here. So it makes the same one as we had here with the automatic. Now, maybe we don't want that. So what we would do is come back in here, get rid of that one, and we're going to select something else. Maybe we want, oops, not what I want. Select a single. Maybe we're going to just go back and forth here. So I'm going to go ahead and hit check. Now, spiral, if you think about this, right, it's saying I want to stay parallel to this. Well, spiral's probably not going to work too well for that. Let's go ahead and check it, see if it even works. Okay, it actually did. It still did it. It's kind of more of a one-way now, essentially. So what it's doing is, you can see here, it's starting, going across, coming up, wrapping back over. It's just taking a one-direction cut. So this would be the same as just picking one way, essentially. Oh boy, now I did it. There we go. All right, so let's go ahead and pick zigzag for this. All right, so now we got a super efficient path. You can see here it's coming all the way, changing directions, coming back and forth, and it's going to zigzag across that path. Now, advantages of that, super efficient. If you're looking for an extremely good finish on your part, it means you're going to be conventional climb, conventional climb, conventional climb. So you're probably not going to get quite as good of a finish because you have that conventional pass, every other pass. So just depending on what you need, what you're looking for, you may or may not be able to use that zigzag. But it is a really efficient path. I use it all the time. I don't have that critical of surface finish requirements, so I'm not too worried about it. But the important thing here is to notice that it is staying parallel to that part that I picked. So let's just go in here and just kind of do one more example where I X this out. And let's do a partial to here. Okay, and hit check. All right, now you see it's staying parallel to that. So it's just offsetting that profile. This is what parallel does, plain and simple. That's what it does. It is an extremely powerful path. You can use it in 2D. You can use it in, well, I should say three axis. You can use it in 4 axis. You can use it in 5 axis, just depending on what you're doing. I actually use these unified paths quite a bit in 3 axis machining, just because they're so powerful and I have so much control over them. All right, so that's what parallel does. We do have some options in here that we'll talk about in a little bit. I'm going to show you containment, but I'm going to do that with morph. We talked about our cutting method. So lanes, this essentially, I'll see if I can get that to work with something. I didn't really set up to show you that, but I'll kind of try and explain it as best I can. Okay, so one thing that I do want to show you. So let's go back to we can do it with this. So trim extend. So you might decide that, okay, well, I'm machining this square. Well, that square has a tolerance, right? So it could be bigger, it could be a little bit smaller. Let's say it's plus or minus 10 on the outside dimensions of that square. Well, if I'm drawing it nominal, it's technically not going to machine very well. And actually, this is a kind of like a fast feed coming around here. It's not going to look right. Maybe you want to extend this path a little past your surface just to make sure it cleans it up and you don't end up with any cusps on the end there. So when you click one of these options under area here, or type, this is your area type. We'll talk about that here in a second. But when you pick one of these options, boom, another thing pops up here, another menu pops up. So what this will do is this will allow us, and let's just make it a value. This will allow us to extend past the edge a little bit. So I'm just going to make it 0.1. And I'm going to make this a value, 0.1. And side extensions. We can actually extend past the sides here, which would be this one. So let's do that one, and let's say we're going to make that let's do a value, 0.1, 0.1. Otherwise, it's going to use percent of tool diameter. I actually prefer just to give it a value a lot of times. Okay, see now it's starting out here, and it's going past in all directions. So now we're making sure that we're covering that whole surface. I use this a lot to make sure that I could machine my whole surface. Now, obviously, if we had some sort of surface that butts up against, we wouldn't be able to do that. So, you know, depending on your situation, you may or may not be able to use this. Okay, let's go ahead and take a look at Morph. So let's change this over to Morph. All right, now this is a change that they made, I think, a year or two ago. You used to have to actually add 2 rows by clicking on here before Morph was an option. Now, if you just add 1 row, Morph's an option, it automatically adds the second curve for you. The reason why, you have to morph from one shape to another shape. So in that automatic row, it's automatically assuming that a circle is in the center, and it's just going to morph your outer boundary, from your outer boundary to a circle. And that's why you don't have quite as much control with those automatic rows. This, we can pick any shape we want. So let's go ahead and select Morph. Let's delete this out. Let's go to Levels. And let's turn on our Morph. I have some prepared geometry here. All right, let's go ahead and select this. So we're going to grab a partial. I'm going to select from here. Actually, check that. I'm going to select from here to here. And for this one, I'm going to select from, oops, got it wrong again, to here. Enter. Okay. Okay. And now you can see that it's morphing from this outside to this inner shape here. Notice how it starts as a point, it slowly progresses to this here 45 kind of chamfered angle here. Now you notice that it's not doing a great job in here. This really isn't what we want to see there. So this is where I'm going to show you containment. So we're going to assume that we're probably not going to machine this, otherwise I'm not going to morph to this. Doesn't really make sense. So let's go ahead and go in to our toolpath and let's contain this. So let's turn on our containment and let's select our containment region. All right, so we're going to select the full chain and I'm going to bring these around, and that's where we want to contain our toolpath. So I'm going to go ahead and hit check and let's see what that gives us. Okay, So that looks pretty good, right? I wouldn't complain about this. Now we do have a few retracts. We have some goofy stuff happening here. And we have some goofy stuff happening here. And I'm going to show you how to get rid of that with Morph, or at least most of the time it'll work. If we go into Morph, and something I want to point out before I show you, you'll notice that I didn't change my step overs. So when I'm trying to get my tool path or my cut pattern, when I'm trying to get that the way I want it, I leave the step over large, I leave the cut tolerance large. Why? Well, I don't want it to take 20 minutes to regenerate. So I just want to regenerate this really quick. I can always turn this down. Most of the time, the vast majority of the time, it is not going to affect the tool path. Once you get it right, it'll just make a smaller step over. Now, with Morph, the difference between Morph and Parallel, obviously it has to change the step over to morph from one shape to another. So with Morph, this is your maximum step over. So it's not going to exceed 50 thousandths within reason. Right now, it will actually exceed it a little bit, only a very little bit. And it needs to do that. And you notice these are closer together. And that's how it creates this morphed pattern. So you give it a max step over, and then it can always go smaller to morph that shape together. Now, the reason we're getting these goofy things right here is because of that max step over. So what we're going to do is go into advanced options, and this is where our step over calculation is set to approximate. So we're going to change this to exact, and let's see what happens. Much better. Much, much, much better. So now we've got an extremely, extremely nice path there. So we're really coming down once, zigzagging in and out, back and forth, and then retracting. That's what we want. Now, when I said there's a process to this, this is what you need to do. I did not even open, and I probably should have, because there's probably some stuff that's defaulted to on. Yeah, like some of this stuff, I should have went in here and just, because I have default set. But if you don't have your default set, essentially you want any collision control off, you want any normal, you just want to have it normal to the surface in this case. So just really simple, and you create that cut pattern. That's what you want to see. Once you have that created, then you can move on to the other menus. So take your time, get your cut pattern right, and then move on to the other menus. Okay, so this looks pretty good. We have it contained. We're doing a zigzag. Now, I did mention that, let's talk about cut order, and then I'll get the machine by. Oh, another option. So before I do that, notice it's starting on the outside, coming to the inside. If I want to flip that, I'm just going to flip the step over. Now it's going to start here. You can see the green, and then there's our orange or burnt orange where it's leaving. It's retracting. So that's how you flip your step over or change where you're starting versus where you're ending. You can also create a start point. Obviously, as soon as I click that, it's going to give me another menu that pops up here. Unclick that, that goes away. Cut order. So we can either do standard, which is going to start at one end, work its way to the other end. We could do from center away, which means it's going to start in the center and it's going to work its way out. Obviously not as efficient, but sometimes you need to do that just based on what you're machining. It's better to start in the center and work your way out. Outside to center, pretty much the opposite of what we just did. It's going to start out here and it's going to work its way into the center. Machine by lanes. So what I was going to explain with this is, and this graphic is pretty good. So if you have like two separate surfaces that you've selected, it will continue and just go in line across those lanes And basically what it'll do is when it gets to this number 7 here, it'll machine this, retract, come over to this one, feed down, machine it, retract, come back to number 8, and it'll keep doing that. If you pick regions, and usually when I have two separate surfaces is usually what I do, or I kind of toggle back and forth to see basically what gives me the best path, what looks the best. So now it will actually machine this whole surface, and then it'll move to this one, do the whole thing, and then it'll move over to this one and do the whole thing. So it's not going to retract as much. You're going to save on those retracts. It's going to be a more efficient toolpath if you have multiple surfaces. So let's see if this changes. If I set this to regions, let's see if it changes anything because of the cut pattern that I picked. Now it doesn't really change much. Actually, I think it did. Let me see something here quick. Let's go to lanes, check. Yeah, so notice that we have all green here, so we're plunging and then coming back. So if let's just simulate this quick. So see how it's stepping around, right? Doing one at a time. Outside, inside, outside, inside. All right, so let's go back and let's change that to regions. And let's take a look. And I have my retracts on, which are like crazy high. We're going to get to that in linking. That will fix that. I left them on so you can kind of see the efficiency of the toolpath. Let's go ahead and hit play. Interesting. So instead of starting here and here every time, now it's starting here. It's kind of going back and forth, which is interesting. I mean, it's not really any more efficient, but it did change it. So it's not plunging or feeding in here on every one. It's actually swapping back and forth, as you can see from the colors. So it did something a little bit different. And that's the thing. You can never really be 100% sure until you have a lot of experience and you kind of know, because you've done it a bunch of times, what exactly it's going to do. So that's why it's important to make sure that you get this cut pattern worked out. Okay. So that goes over essentially all of these parameters. We discussed containment. I'm actually going to turn that off. I'm going to turn trim extend off. And let's go ahead and let's go and do actually, while we're in here, let's do a perpendicular. All right, and let's select a different edge to be perpendicular to. Let me turn my morph level off and leave my surface off. Let's rechain this, and let's just do a single yeah, I didn't realize that was a broken line. I forgot. Let's use this one. Okay, check. All right, so now we're perpendicular, and this is going to do exactly what you think it's probably going to do, or hopefully what you think it's going to do. And it helps if I change a couple parameters in there, because this looks goofy. Because remember, I still have it set from outside. So let's do standard, and let's do lanes, and let's put it on zigzag, and that should fix all the problems that we had there. Okay. So we picked this line up here. Obviously, the cut pattern now is perpendicular to that line. Now, sometimes this is useful for surfaces like this. Where this is really useful is if you're doing porting. So an example would be like if you have a port of some sort, like we did like an elbow fitting, kind of like a pipe elbow fitting. And when you do those, you create an axis, essentially, or a center line down the middle of the port in the elbow fitting, and you select that as your geometry here, so one of your entities, and then if it's perpendicular to that, it's going to create a spiral on the outside of those walls, because obviously you pick the walls as your geometry. So that's where that's really useful. There's other places it's useful, but that's just one of the ones that came to my mind when I think of using perpendicular. Obviously, you can use it here or wherever you want as well. Let's take a look at guide. So let's go to guide. Okay. We got zigzag on, standard, one direction. Okay, let's see what happens with guide here. All right. So guide essentially does the same thing as parallel. If you just select that line, it's just going to use that as a guide curve. Now, I don't use guide very often. Sometimes it's advantageous, but the ones that I use the most are morph and parallel. But let's show you what the power of guide is. And let me just go to my levels here. And let's do guide curves. Okay. All right, so let's select. Helps I have chain on. Chain, check. Check. Okay. Now you can see, essentially, it's using that geometry to guide your toolpath or your cut pattern there. Now, you also notice that it cuts on both sides of the line. Well, we can control that. So we can tell it, hey, maybe you don't want a machine on the inside, or maybe you want a machine on the inside of there, but not the outside of there. So what you can do is, number one, have machine tire area. That does, you'd probably think this is where you set it. It's not. What you would do is come in here to guide curve advanced parameters and propagation direction. So we could say left, and I'm not sure which one is which for a closed loop. Obviously, if you have a single line, left or right can be probably pretty easily determined by going to your top plane. But let's go ahead and hit check and see which one. Okay, so this one's the center, left. You just have to try them and see which one's going to give you what you want. So now it's doing everything outside of that guide curve. So that's what a guide curve does. We can also add more than one guide curve. So I can go to guide and, I can let's grab this one, check. Now, this here machining advanced parameters, this gets a little bit hairier where it's harder to say where it's going to machine. It usually doesn't machine in the center now. Usually it'll machine everything but the guide curves when you have more than one. But you can see here, now it's using both of those, and it's actually kind of morphing the whole thing between them, which is pretty cool. That's a pretty efficient path for this. Okay, so that's essentially what guide does. Again, we have direction, so direction 1, direction 2, they don't call it climb or conventional, because depending on what side of the cutter you're on, it can get very confusing with 5-axis because you're not always on a planar surface like this. So basically you just kind of have to see which way it's going and then figure out whether you're climb or conventional, and then you can swap these either way. Cut order, obviously we can, couple different options in here and couple different options in our cut method, same options essentially. All right, so looks like we're pretty much covered everything that I wanted to cover in these here for our cut pattern. Yeah, so let's take a look here to see. I think we got everything we wanted to take a look at. All right, so this will conclude our video on cut patterns. So again, didn't go over everything in there. There's a lot. These are powerful toolpaths. They have a ton of options, many of which I've never used and don't know how to use until I try them. So when I do want to figure something out, like when I'm trying to get the toolpath to do something, I will click one option at a time, see what it does. Doesn't do what I want, I'll go unclick that, click another option. That's the best way to figure out how to use some of this stuff. A lot of what I have learned is self-taught. Just reminded me of something. Some other stuff here is surface rows. So you can actually use surfaces to create your cut pattern as well. So if you don't have like geometry, you can also create surfaces. So for instance, let's see here. I actually have a surface here that I can use. Whoops, not Morph Geo. Let's do guide cylinder. And let's go ahead and hit check. And we also have the left, check. And there we go. So I picked that surface to create that. That was something I almost forgot to go over there. So you can use surfaces as well for your cut pattern, which is right here, add surface row. You can actually add a plane row. So add a plane row. Let's see here. So our front plane would be like this. You see right here, this is our front plane. So if we pick that, front, check, check, right there. Now it's parallel with that plane. So you can pick a plane row. I don't use these very often. I might have only used those once. And then, of course, remove all rows. You can just delete everything out. Okay, so that is the last thing that I wanted to go over. Hopefully everybody knows what step over is, scallop height, and what cut tolerance is at this point. Please join us for our next video. We're going to go over tool axis control, and we'll pick up from there. So what I'm going to do here quick before I leave for this video, we're going to go to parallel, and I'm going to select this line here, check. I'm going to turn off that level, and I'm going to hit check. Uh-oh, I have something selected wrong. Of course I do. Why not prolong this? Okay, zigzag, flip step over. Wheels. Oops. Where is it? Square surface. Pick that. Check. Lanes. User input relative to guide curve is set to left or right. Guide curve is within. Okay. There we go. So, I'm actually glad that happened. Sometimes if you have this set on exact, it will give you problems. So you have to go in there and change that back to approximate. And you can see there we still got a great, turn this surface off. We still have a great toolpath. So we're going to pick up right here when we come back for tool axis control.